Your line has been muted.
All right, all good? Okay, all right, let's get started then. So, guys, welcome to Young Minds. This is going to be the second segment of this of the series. And I'd like to start with a quote from one of my favorite war gurus, The Art of War by Sun Tzu, and he says, "Whoever is first in the field and awaits the coming of the enemy will be fresh for the fight. Whoever is second in the field and has to hasten to battle will arrive exhausted." So the aim of this series is to get all of us first to the field. It's a complex field to go into Platform 3, but one I think that we absolutely have to adopt. And the whole idea of Young Minds is really a mind that's curious to learn, self-motivated, balanced, passionate, innovative, and collaborative. We're going to need all these qualities to be able to absorb what is, generally speaking, a very different world from the world of storage and backup that we usually live in the Platform 1 and Platform 2 spaces. But it should be a fun ride, so hang with me as we go on. We talked about the 3 platforms, and the focus for this, of course, is what really new happens in the 3rd platform with mobile and cloud and big data, etc. And this segment will explore a lot of these ideas. And I'd especially like to focus on the fact that the future growth of EMC is most likely going to be heavily in the 3rd platform than anything else. So without any further ado, let's get started. So this is roughly what I would like to cover for this particular talk track over here. As you know, I'm trying this new format with whiteboarding, and most feedback has been that whiteboarding is an effective way to communicate. So this time we're going to talk about world hunger. We're going to talk about farming, corn and soybean, and you're probably wondering what this has got to do with any Platform 3 stuff, but that will become clear in just a few minutes. And I'll talk a little bit about software development life cycles. What is the difference between traditional waterfall method, which we talked about in the last time, and agile development methodologies. And then let's take a trip into a day in the life of a developer and why the frustration there forces them to go to things like Amazon Web Services, and what is the motivation behind Platform as a Service, and why is this really all that interesting? Right. So I'd like to start by by this little story about a company which was actually a pretty sort of brick and mortar type of company. All right. Hang on a second. Let me get this thing working here. Oops. Maybe not so easy. I don't know what's going on here. Okay, there we go. So if you look at this company, it's actually a pretty brick and mortar type of company. They, at one point, they used to make a bunch of chemicals. Then they realized, as time went on, that they owned some intellectual property which allowed them to get into the seed and farming business. So this was a very interesting switch for them, and they realized that, hey, I could plant seeds in a particular farm, say in Hawaii, and I could grow crops over here. And I could plant another set of seeds in another form, say in Brazil, and probably, plant the same seeds over there, and they grew differently. And over years of research, they started to identify that there's ways for us to actually cross-pollinate these and be able to manage which seeds flourish well in what kind of soil conditions and humidity conditions. So ultimately, this all boiled down to what happens inside the seed. Over 50 years or so, they realized that, hey, I can actually manage these seeds pretty effectively, because I could take my seed and I could use some modern technologies over here to fully sequence the seed's genome. Right? So they actually carve out the DNA for these, and then do some much deeper analysis for this, and through analytics be able to figure out what genetic sequence is going to work best for what kind of soil conditions. So they wanted to actually chip the seeds and sequence these and analyze these, and the way they did this was a pipeline which had obviously Gen 1 and Gen 2 sequencers over here, but they used HPC workloads and they used Hadoop to be able to do the rest of the analysis over here, and they were using Exadata over here to do a lot of the structured data analysis. Now, just to give you an idea of what kind of an environment this is, understand that, you know, the kind of stuff that they do over here is expected to be about 75 petabytes of data very soon. So this is a non-trivial amount of stuff that they have over here. Then they realize that it's one thing for us to be able to identify what kind of seeds we have, so they have the ability to predict and modify, you know, what the seeds were and where seeds work best. And knowing where seeds would flourish was only one part of the whole picture over here. What they really wanted to do was to say, hey, now what about the farmer? You know, the farmer's got their farm over here, and we would love to be able to match the farmer's, you know, farm to the seeds that we have. And the farmer grow their own crops, right? And they had their planting, and, you know, of course, they have tens and millions of acres over here. And they would harvest using whatever, you know, some kind of devices like harvesters and tractors. Sorry for my pictures. It's a pretty bad picture of a tractor, but that's the way I draw. And what they realized is that if you could put a sensor on these kind of devices which go through the farms, you could actually, you know, take that data and through, you know, wireless techniques, be able to move this data into, from the farm all the way into the corporation. What that allowed people to do was something very interesting, that allowed people to take the data which was inside the genomic databases and actually match them to the farms that, you know, we have to actually plant them on. So as you can imagine, this means that you could really develop techniques to be able to maximize the yield on every farm that you have. So much so that, you know, people expected that maybe 20% increased yield from each farm could be achieved if they just had the right kind of crop, you know, crop seed matched to the right kind of land over here. As you can tell, this is a very interesting sort of big data problem. And the CEO for this company really christened this whole project, you know, to solve world hunger. And they weren't exaggerating, because you do this right and you could go to arid lands in Africa or India, and where it was tough to get high yield, and if you develop seeds that are drug resistant and insect resistant and stuff like that, you could actually maybe really solve world hunger, which is a tremendous thing. Now, a couple of things to note about this. This required very massive, you know, distributed apps to be able to deal with. At very, very massive scale, because it wasn't just that, you know, you had to run these applications. A lot of this was sensor-based data, right? Sensors from the tractors and harvesters that you had over here. And the workload was very seasonal, in the sense that when planting time and harvesting time came about, then obviously you had to have much more activity in collecting the data, because that was sort of the critical data that they had. And this implied really serious big data and fast data analytics. These kind of characteristics meant that the traditional platforms that they ran on would really not work at all very well. So they had acquired a company which made these sensors, and as that company was already doing a lot of sensor processing on Amazon Web Services, their initial gut was, hey guys, let's just go out to the cloud and build this, because clearly this is not something that our internal infrastructure can handle. So once again, it's a coupling between the seed genomic data, which they had in structures over here, with the sensor data from the farms, which came from here, to be able to match these to maximize yield. And ultimately, the goal is to solve world hunger. Now, how would somebody actually go about doing something like this? And more interestingly, what has EMC got to do with all of this, right? So what we looked at that point was, you know, the account team in question over here, and I'm not going to disclose their name or their location just because, you know, it's a very, it's an innovative architecture, but a relatively sensitive customer. But understand that, you know, what they looked at is to say, okay, if we're going to do rapid deployment of these kind of applications, why don't we do it, for example, on Amazon, because we're already there. Now, when you look at that, you say, okay, so I have AWS over here. What are some of the advantages of going to Amazon? Well, first off, we could develop at scale. And scale, like I mentioned, because of the seasonal variation, is a critical parameter over here. And there were the incumbents, right? We're already using the stuff over there, so why not just, you know, stick with it? Now, the downside of this is that once you reach a certain critical mass of data, say you have about half a petabyte of data up on Amazon, if you do calculations on what kind of network bandwidth it would require to move the data out, it's absolutely phenomenal. So if you had 500 terabytes for even some of the faster links that you can get to Amazon, this would imply that this would take you 30 days to get the data out of Amazon. So once you crossed a certain threshold, a certain event horizon for the data gravity that you have on Amazon, you are pretty much stuck there. It was like a black hole, because it would absorb the data, but there was absolutely no way to get out of it. And they weren't particularly enamored with the fact that this would lock them into Amazon. So this is where our teams came in, and we said, you know what, why don't you run Cloud Foundry on top of Amazon? What this does for you is something very interesting. Cloud Foundry, and we'll talk a lot more about Cloud Foundry and why this is so interesting and, you know, exciting. But one of the core things it did for the customer was that I could build another totally parallel infrastructure inside my data center. I could build, for example, a vBlock-based infrastructure as a service, and I could overlay Cloud Foundry on top of that. And what this overlay did was that it made my applications completely portable across these two clouds. And Cloud Foundry has the very interesting property, and we'll go into it in quite a bit of detail, as to, you know, making applications move between one cloud and another. And this is what really convinced them that they need to throw in with us with this whole thing. Of course, they looked at a lot of other kind of things as well, and one of the things that, you know, they looked at is, hey, this is all about rapid ingest, right? Rapid ingest because it's sensor data. And when you do rapid ingest, that means it begs technologies like Gemfire, because Gemfire does very rapid ingest. It's an in-memory fabric. We'll talk about that some more. Then we already talked about cloud portability. And what cloud portability means is that you need something like Cloud Foundry in this whole mix. They needed reliable messaging. And reliable messaging, there's none better than RabbitMQ, which also is something which is in Platform 3 portfolio. So all of this really led to the fact that they should invest heavily in us. They wanted to do a lot of the application development in Spring, and they were adopting Agile methods of development, and we'll talk more about Agile as well as Spring in subsequent lectures. And I want to highlight what this really ended up in. Last year, they bought $12.5 million of services from EMC Consulting just to help them on this journey. At the heels of that, we have a $20 million software ELA, which should kick off very soon. And oh, by the way, what infrastructure should they actually run this on? It was almost a no-brainer. They said, let's do vBlocks. So there's a $2.5 million deal for vBlocks on the docket right now. And this is only the beginning. They liked the story about converged infrastructure with Cloud Foundry running on it so much that they basically said, let's standardize on this. And across the board. And to give you some context, this is a company which, generally speaking, has viewed us as just another storage vendor and had no real distinction between us and any of the other vendors, and we've always had to fight for every ounce of business over there. If we go through this year successfully and we're able to do this, this means that this could suddenly overnight go from maybe a $5 million to a $50 million company. Now, hopefully you guys are looking at this and saying, wow, that's a hell of a transformation. But I want to emphasize that this is driven by solving a business problem. And ultimately, it's the business that's going to really allow you to go here. Rather than working with IT, we'll literally have to change the profile of what we're working with in this space over here, right? So to understand what's so hot and exciting about Cloud Foundry, we have to expand our horizons a little bit, and say, okay, what is it that is so exciting about Cloud Foundry, and what is it that's interesting about Platform as a Service, And to understand this, we got to look and see how people do software development. That's not an easy thing to explain in a short bit of time, but I'll try to do it justice, right? And the key thing is that when you do software development, one of the things to note is that, the way people do software development right now is, first of all, it's very collaborative. You have teams of people who work together, and they basically, work and use a different set of tools. They may use different sets of languages, all kinds of stuff. And to be able to allow large collaborative projects like this to work effectively, they usually adopt what's called a software development lifecycle kind of methodology. Okay, so they have some kind of technique in which they actually do this kind of development. And I'm going to talk about a couple of common methods to do this. One we talked about briefly, which was the last time, which was a waterfall method of development. But more interestingly, I'd like to talk about something called Agile. And there's a variety of tools which also come with this, and we'll also speak a little bit about the tools as we go on. So your traditional waterfall methodology is relatively straightforward. It's highly sequential, so you start with requirements, and then based on that you do a design, and once you have a design, you usually start to test it, and then based on the test you would deploy it, and then you would maintain it. If you notice, this is the reason why it's called waterfall, because it's a cascaded method of being able to go from the initial definition of the problem till the final kind of solution and its support. So this is not bad by any means. Most traditional software development happens with waterfall, and it's very good if your requirements are well known. Now, this may not always be the case, because in modern projects, as you might imagine, there's a lot of stuff which is, changing, and one of the drawbacks of this kind of method is that there's no real good feedback loop. The projects are large, and they tend to be complex and monolithic, and what that means is that as you start to define these things, and you've gone down a certain way down the path, it's very difficult to reverse back and make any changes along with this. So this makes it very time-consuming too. So it is not unusual to see 6 to 12 months as a life cycle for being able to work in an environment like this. And for the modern next-generation applications, such as the one which I was talking about in the previous slide, as well as those driven by Platform 3 initiatives, such as mobile and social, you rely on rapid iteration, you rely on being able to converge very, very fast, and that's usually the way that you work with it. Now, we contrast that with something which is known as Agile, right? So how does Agile work? Agile, you start with a project backlog, which is what you need to get done, and then you break that up into small, manageable chunks, which are, some people call them sprints, right? And as the name suggests, it is a sprint. And the way this cycle works is you take a sprint and you go around and you start to work through this cycle. And the cycle is typically 2 to 4 weeks. And each day, you basically come together and do what's called a scrum. And you'll hear such terms like this. A scrum is a term that comes from rugby. Quite literally, the whole team gets together every day and says, exactly where are you? And they make commitments for what they're going to do in the next day. The way the projects are structured are, if I need 50 features, what they start with is the most important features. And they code the most important features as a team. And as that coding gets finished, they immediately build the product as quickly as they can to make sure that the entire product is working. The customer is constantly interacting with them, and this is what really makes it very successful. So we start with small chunks instead of the whole thing at one time. We build and test constantly, which means you don't wait till the end of the project to do testing and integration and stuff like that. You have a product which you have ready. So in fact, in many cases, once every 2 to 4 weeks, you can actually come up with fully running code over here, which you can actually deploy. So if you have finished the top 6 features that you need, you may decide, hey, you know what? Maybe I want to deploy this into production, and I'll work on the remaining 44 elements that I want over time and start to accelerate this. As you can see, this really means that it's very, very rapid in its convergence, and this is what makes Agile extremely popular. So you have usable code at every step of the way in this kind of a process, and to enhance code quality, they use techniques such as pair programming. And what pair programming is all about is 2 people do the coding simultaneously. So they can teach each other, they can catch each other's mistake, and that's really what accelerates the whole process over here. And so the deployment of this is far more rapid than what you would in the traditional waterfall technique. This is not to say that waterfall is bad. Waterfall works fine for well-defined projects where you have a well-defined final state. But Agile is very popular because very seldom in modern-day applications do you actually know what is the well-defined requirements of the project up front. Often you want the customer to come and look at it and say, oh, okay, I like that, or okay, maybe I don't like that, can you change this to something else? And this kind of a methodology allows you to be able to work with this very, very effectively. So these are the things that make Agile cool. And Agile being cool is one of the things that we really depend on as a company, because we find that this is really, really strong as a method to be able to help customers go towards some of these newer gen technologies. So, the other thing to understand is that it's not just the software development and the different methodologies that we have over here. At the end of the day, we have to look to see, hey, why is it that developers are drawn towards places like AWS? So we should have a look at what happens in the day of a software developer that they don't like at all. Because, you know, what a software developer or a team of developers may do is they may develop various applications, and often as part of the same project, right? Applications will talk to each other through some middleware, and we'll talk much more about middleware like WebSphere or Tuxedo. They may in turn talk to other applications also. And there's a complex web of things that happen over here, and they all have some sources of data. So some sources of data may be a relational database. It could be a NoSQL store, and if you don't know what this is, I'll come to that as we go through this entire series. They may, look at other stuff also, like an MPP database, or maybe Hadoop, or a whole bunch of other technologies over here. And there's lots of intricate connections between all of these. Now, it takes a while to get the data services set up, but it takes even longer to actually get the application set up, and even more so to really look at the application and be able to scale it. Now, in the traditional world, what the developers do is they will take this and they will use a combination of languages and stuff like that, and they will put this in an integrated development environment, also called an IDE. So if you're wondering what an IDE is, it's an integrated development environment. A common example for this is something called Eclipse, very popular. Almost all languages can be coded in over here. But inside this IDE, they would be the place they would initially write their code. Now, they go through their development and they collaborate and they come up with this, and now the question is, I'm done with the coding, where should I deploy this? This is when the problem really starts. Of course, there's many tricks we can use to help customers do this, including frameworks like Spring, but at the end of the day, what we're concerned with is a problem that they all face, which is, I have my IDE, and I have my code which I've written in it, and now I need to be able to actually deploy this. This turns out to be kind of where the rubber meets the road, and we have a lot of problems in this system. So what typically happens is, the first thing is you have to build a runtime environment. And a runtime environment might be, hey, I'm running Java, so I need Java virtual machines, I need a Java runtime environment. There's a whole set of things around there. But then if I want to build a runtime environment, the next thing I have to do is to bind to my data. I may have Oracle or, whatever kind of data, SQL Server data out there, or Hadoop data out there which I need to work to, and I need to bind that to that. Then all this needs to really sit on some kind of operating system. So someone's got to install an operating system and the patches and all that. And someone's got to go out and build the virtual machines where this operating system is going to sit. And then I'm going to build the server farm that this is going to sit on. And then build networks. And then I got to build whatever's needed from the storage side. As you might imagine, this process is painful enough as it is, but this is just for test and dev. So this is not even for when you actually do this whole thing over here. And then once you're done with this kind of a process, you then face the other problem, which is I got to take this application and I got to scale it. So the whole sequence starts all over again. A lot of times, just this process alone takes anywhere from weeks to months. And this is really the story with most of our customers. It's extremely time consuming, lots and lots of people involved, it's hard to change, and it's not just changing this that matters, it's impossible to scale. If I wanted to now say, hey, I want 20 copies of this app over here, I got to scramble around and go through the whole process again, and that really kills it. And there's just too many handoffs. It's like too many people involved. You got to talk to the server guy and the operating system guy and the virtual machine guy and the network and the storage guy. All of this, as you go through workflow, is really, really painful. So reaction from most people who are trying to deploy new kind of application is enough. Can't handle this anymore. So what do? You say, okay, let me go to something like Amazon. So what Amazon does for you is it takes this bit of it and it says, I'm going to automate this whole thing. And when you go over there, well, I am still stuck with doing the rest of the stuff on top, which is building the runtime environments and binding to data and building an operating system and figuring out how to scale it. Oh, by the way, I forgot to mention that as you scale it, you also have to add other elements to this architecture, such as load balancers over here, to be able to distribute the workload. So even more network work. This is not at all easy. So in contrast, what people really want to do is say, can I just have something where I just dump my code and it does the whole thing for me? So this, my friends, is what is platform as a service. So what Cloud Foundry does when it sits on top of an infrastructure service, and it could be Amazon, and it could be a vBlock, and it could be an OpenStack environment, it says, I'm going to do this, and I'm going to do this. So all the developer has to worry about is their world over here, and when they deploy, they're able to scale it as effectively as they want to, and moving from here to production is not a headache, and taking this and running it in and scaling it is not a problem, and you can run it on any cloud you want. If you want to run it on Amazon, great. If you want to run it somewhere else, that's fine too. All right, so hopefully I've given you some feel for what this kind of a life cycle is really all about. So let me quickly recap over here. So we started out by looking at what happens in a farm and what the problem was which they wanted to solve, which is world hunger, and looked at a combination of technologies like sequencing and sensor analysis to be able to figure out where one should actually deploy stuff and where one should plant stuff. Now, the reason they were drawn towards EMC is because they saw us as having the most complete portfolio to be able to deal with this, because we offered them cloud portability, very rapid ingest through Gemfire, and reliable messaging with Rabbit, as well as consulting services around Spring and Agile. This lets them get the time to be able to build an in-house environment with Cloud Foundry and with Platform as a Service, with Infrastructure as a Service as a vBlock under it, giving rise to a strong revenue opportunity for us from consulting, from software from Pivotal, and from vBlock type opportunities, allowing them to standardize and scale very rapidly. Now, the exciting thing about this, of course, was that we needed to understand different ways of doing software development. And we contrasted what we did with waterfall techniques with Agile, and the fact that we as a company can help our customers learn how to do Agile coding, and to be able to work with this is very, very critical. And lastly, hopefully you understood why, if you step into the world of a developer, you're left with this maze over here of things which you have to get done, and you don't have enough time to do that. And you want to contrast that with going into either Amazon with Infrastructure as a Service, or even better with Cloud Foundry, which is Platform as a Service, running on top of Amazon, or on a whole bunch of other stuff. So I've gone on for about 40 minutes, guys, so I'm going to stop at this point. following experiences from last time, I think if you star 6, you can ask questions. So let me pause right now and see if anybody has any questions. Anyone out there? Yeah, I don't know if anybody can. I believe if you star 6, you can unmute. Can somebody star 6 and just verify that he can unmute? How about now?
Hi, Karthik. This is Raman. Can you hear me?
Oh, hi, Raman. Yes, I can hear you. Thank you. All right, appreciate that.
So, quick question on something that you covered kind of quickly. The portability of the software. You mentioned that these guys went to us because we can do this on top of Amazon. We can do it on top of a private cloud.
Yep.
What are the mechanicals of that piece? Once they're ready to, let's say, migrate the code to test dev, is that do they kind of decide at that point that they're going to build a private environment and then just move all the code over? But the part I'm fuzzy on is the data access layer. How does that code continue to access the same data, or is moving the data part of moving the code back to the private cloud?
You would have to move the data also as part of moving it back in, which is why the event horizon that I talked about of having, you know, over a certain kind of critical mass over here, you end up with real issues. So you would have to move the data back. Well, what Cloud Foundry does is it makes it extremely simple to take your existing code and be able to redeploy it on a different cloud, literally with a one-line command. I'll go through that in some more detail as we do deep dives into Cloud Foundry, and as that it'll become much more clear on how we orchestrate this.
Is there a path from a practical perspective where they just access, let's say, a certain amount of test data while the like as raw data, the master data is moving back in the background? Is that something that's mapped out, or that's too far in the future?
It's for this particular customer, we are still working on the initial architecture of how to work out the details, what data sources they would be. In general, yes, you would work out what kind of data sources you need and what kind of test data you need to be able to do something like this. Okay?
Yeah, thanks.
Any other questions?
Hi, Karthik. This is Todd. I've got a question around access control. Does Cloud Foundry handle access control between AWS and the platform as a service in the private cloud as well?
Usually the kind of security infrastructure you need for authentication authorization is something you would invoke as part of the application itself. So there is a very rudimentary governance framework also, which ultimately we should be able to leverage. But generally speaking, that's left to either the infrastructure as a service or to the actual application logic itself to be able to manage things like, you know, logons and governance and, you know, patches and security and stuff like that. So Cloud Foundry really is, as it says, it's a platform. It will allow someone to write code in varieties of languages and different frameworks. Just to give you some examples, it will handle Java as a language with Spring, and next talk we'll talk about the difference between languages and frameworks, or Ruby on Rails or something like that, and it'll allow you to develop applications and deploy on it. And the advantage here is that you hardly have to do any more work after that. This is very developer friendly, and you basically take it straight out of there. If you like, I can cover some of the more, you know, security-oriented aspects of Cloud Foundry when we go into that in detail. Somebody else had a question?
Yes, Karthik, Mike Gills here. Could you expand just a little bit on the reliable messaging and what services RabbitMQ delivers?
Sure. We'll talk more in detail about RabbitMQ, but roughly speaking, if you look at messaging, like say MQCDs or something like that, a lot of that work is done, integration is done with APIs. RabbitMQ's main claim to fame is that it does this based on a protocol called AMQP, which is actually an industry standard. So it does protocol-based messaging between different services. So Rabbit actually was one of the most interesting, was the first thing we introduced to this particular customer. And they really liked it because it was a very lightweight and very reliable and simple way of being able to connect applications without having to change code all the time, and instead they could do it with a protocol. Much more on that as we go on.
Got it.
We'll do a deep dive into Rabbit. Any other questions, guys? Okay, we're at a little past 2:45, which is about the length at which I wanted to keep these at this point. So thanks much, guys, and as always, welcome feedback. I really want to know if this is useful, if we're going on the right track. Just so you get some feel for what we do, what is planned over here. Let me show you a quick draft of what we have from a Young Minds curriculum standpoint. So we'll be covering a lot of stuff, including things like, so we are currently in segment 2 right now, and so the first one is platform 1, platform 2, platform 3. We'll talk about farming, world hunger. Next segment, we'll talk about the basics of languages and frameworks, what DevOps means, what Java, Spring, Ruby, Rails mean, what Chef and Puppet mean. We'll dive into Cloud Foundry after that into some more detail, actually watch what happens when that developer releases code into Cloud Foundry. We'll talk more about BOSH, which is the interface layer between infrastructure as a service and Cloud Foundry, as well as a layer that does some of the DevOps and what kind of data services are available. Then we'll start to slowly go from platform as a service into infrastructure as a service. Talk about the idea of infrastructure as a service, common stacks, what are the cloud provider interfaces for Cloud Foundry, management and orchestration stacks in segment 6, BCAC, OpenStack, how, when you combine that with the vBlock, you actually get infrastructure as a service instrumented. We'll look at a couple of others like CSC BizCloud and Amazon Web Services. Then we'll come to how applications interact. So to your question, Mike, we'll talk about MQCs and Rabbit, what REST, SOAP, and web services mean, what enterprise service buses are, dig deeper into how to interact with data, not just between applications, relational database systems, MPP systems, what the NoSQL revolution is all about. Dive into Hadoop and Isilon, more about NoSQL, things like HBase and Redis and in-memory fabrics. Talk about Gemfire, which is our in-memory fabric, which is amazing, and talk about some of the features of that, on how it allows you to do streams processing and real-time intelligence, and start to go back to the farming example and put these pieces together and say, why were these so interesting for them, and what kind of solutions can be built out of that. And then we'll move into analytics, the basics of analytics, SQL, NoSQL, what data warehousing is, etc., and then ultimately culminate in how do we bring in unstructured and structured content into building what's referred to as data lakes. In the last one, and 17 segments so far, 34 weeks, this should take us through the end of the year, we'll take the 3 major focus areas: platform as a service, building data lakes, and cloud technologies, and what all of these mean when you take it together. Okay, so just a quick preview. I'm still massaging the overall kind of curriculum. As soon as I get it finalized, I will get this fully published so everyone has access to it, so you can plan it. We are going to probably take these, edit them, and put them onto EduTube or EMC1. Still working through the logistics for that. Last week's lectures are ready, so we are now looking to post them so we can take a look at it. We will edit these into segments, and then we'll work with that, okay? So, guys, thanks much for attending, and we'll talk to you in a couple of weeks with the next series, with the next part of the series. Take care. Bye.